Assalamualaikum everyone in here. So today we are going to continue our lecture with the fourth part of chapter 1, that is the chain rule and implicit differentiation. So basically the chain rule and implicit differentiation is in here is a continuation from what you have learned in engineering mathematics 1. So it's just a recap or a review, but in this context you are going to learn about more than two variables of implicit differentiation. Okay, so the chain rule and implicit differentiation. So what does it mean by the chain rule? Slideshow from current. Okay, so the chain rule and implicit differentiation is a formula for differentiating composition function, meaning that your function, in your function, there is also another variable that you want to differentiate. So we are going to use the chain rule. So let's say you have a function of z that is function of u and v. U is a function of x and y, and v is a function of x and y, by which all of these functions z, u, and v are differentiable. Okay, so if you take a look at this function, we have z equal to f u v, function of u and v. U and h is a function of x and y. So we want to find the derivative of z with respect to x. But if you take a look at here, z does not depend on x, but it depends on u and v. And v itself is a function of h, xy. So that's why how we are going to find the derivative of this function when the respective variable that we are interested is not in the function itself. So in this case, we are going to apply the chain rule and implicit differentiation. So to find the derivative of z with respect to x, it will be equal to find partial derivative of z with respect to u, because the variable in here is u and v. So we have to differentiate partially u and v first, and then differentiate u with respect to x and v with respect to x. Okay, because u because if you refer here, u is another function, this one, u is this one, function of g, and v is a function of v. That's why we have to find the derivative of u and v with respect to x, multiply with the derivative of function z with respect to u and v. So this is what we call by chain rule, okay, composition function. So from here, if we want, the same goes if you want to find the derivative of z with respect to y. So delta z over delta u multiply with partial derivative of u with respect to y plus partial derivative of z with respect to v. Okay, partial derivative of z with respect to v and differentiate partially v with respect to y. So this is what we call chain rule. Okay, so it involves a change. Differentiate u and differentiate v, and then find partial derivative of z. Then we multiply each one of these. So let's take a look at example to get a more clear picture in how we are going to solve the partial derivative. So example 1.27, use the chain rule to find partial derivative of z with respect to x, partial derivative of z with respect to y, if z equal to u to the power of 2 plus v to the power of 4. So macam mana kita nak selesaikan this one? So u equal to, let's take a look in how we are going to solve for this one. So we have z equal to u to the power of 2 plus v to the power of 4. Okay. So from here, we have z equal to function of u and v. Okay, and if you take a look, u is a function of xy and v is a function of xy. So delta z over delta x equal to delta z over delta, tengok formula dia apa? Delta u, okay, multiply with delta u over delta x plus delta z over delta v multiply with delta v over delta x, partial derivative. So, dapatkanlah satu persatu. This one. Cuba bezakan z terhadap u. Okay. Z equal to u kuasa 2 plus v kuasa 4. Partial derivative of z with respect to u dapat 2 u. Okay. And then another one we have u sama dengan x kuasa 2 cos y. Delta u over delta x. Dapat 2x cos y. Okay. Bezakan u terhadap x. And then v equal to x y cube delta v over delta x sama dengan y kuasa 3. Because we will assume y kuasa 3 as a constant. So bezakan x kuasa 1 akan dapat x sahaja. So substitute everything in the formula. Masukkan dalam delta z over delta x. What will you have in the formula? Okay. So by using this formula, delta z over delta x akan sama dengan delta z over delta u, 2u, delta u over 2 delta x, 2x cos y plus delta z over delta v. Okay, kita tak cari lagi. Delta z over delta v akan sama dengan 4v kuasa 3. Okay. Equal to plus 4v kuasa 3 multiply with y kuasa 3. So u gantikan with this one. It's stated in here u sama dengan x kuasa 2, v sama dengan xy kuasa 3. So finally, our partial derivative will not have the term of u and v. It will only consist of x and y. That is what we call by chain rule. Okay. So 2u, you akan dapat 2 x kuasa 2 cos y multiply with 2x cos y plus 4 x y kuasa 3 dikuasakan 3 lagi. Okay. Multiply with y kuasa 3. So, dia akan dapat 2x kuasa 2 darab 2x. This one will become 4x cube cos squared y. Okay. Tambah 4x kuasa 3 y kuasa 9, 10, 12. Y kuasa 12. So this is delta z over delta x. Fine? Dapat semua? Dapat Semua tunjuk tanda bagus semua dapat lah. So cuba buat delta Z over delta Y pula. By using the same approach, find partial derivative of delta Z over delta Y. Okay. So delta Z over delta Y akan sama dengan delta U over delta delta Z over delta U. Okay, delta Z over delta Y, delta Z over delta U multiply with delta U over delta Y plus delta Z over delta V multiply with delta V over delta Y. Okay. Kita bezakan U pula terhadap Y. So delta U over delta Y, this one. Dapatkan okay, delta U over delta Y. Bezakan 2x cos Y. Dapat apa? Negatif x squared sin Y. Okay. Delta U over the, okay. Negatif x squared sin Y. Dan bezakan delta V over delta Y akan dapat dia sama dengan 3x Y kuasa 2. Okay. So masukkan substitute in the equation ni akan dapat delta Z over delta Y akan sama dengan 2U darab negatif x squared sin Y tambah delta Z over delta V is 4V kuasa 3 darab 3XY kuasa 2. Okay. So dapat yang ini. So substitute in the equation. Substitute in the equation. Tulis kat sini senang. Delta Z over delta Y equal to 2U darab negatif X squared sin Y tambah 4V kuasa 3, 3XY kuasa 2. Okay. Sama dengan 2 darab dengan U, 2 darab X squared cos Y darab dengan negatif X squared sin Y. Okay. Tambah dengan 4V adalah XY kuasa 3, 3XY kuasa 2. Sama dengan dapat negatif 2X kuasa 4 cos Y sin Y. Tambah 12 X kuasa 4 Y kuasa 11. Okay. Oi, dapat Okay, dapat. Those who have finished, try the next example. Example kedua. So kalau dah ni angkat tanda tangan. Bagus beramai-ramai. Okay. Ramai yang dan. Ramona dan. Semua simbol Ramona keluarkan. Hati bergetar. Okay. Rabiatul pun dan. So, cuba try the next example. So the next example, kita ada this one. Dan ni. So example 1.27. Okay. Suppose that W equal to X, Y plus YZ, where Y equal to sin X and Z equal to exponential of X. Use an appropriate form of the chain rule to find dW over dx. Okay. So W, ya Allah. W sama dengan XY. W equal to, kalau awak tengok yang ini semua ada dalam sebutan ni. W equal to XY tambah YZ. Okay. Y sama dengan sin X. Z sama dengan exponential X. So dia kata use appropriate form of apa nama dia? Chain rule to find dW over dx. dW over partial derivative of dW over dx. Okay. So partial derivative, this is actually supposedly is partial derivative, supposed to be delta. So in here kita bezakan satu persatu dahulu terhadap X. Okay. So delta W delta W over delta X, you will get 1. Okay. And delta Y over delta X, you will get cos X. Okay. And delta Z over delta X, you get exponential of X. Okay. So from here, to get the partial derivative over W over X, it will be equal to partial derivative of W with respect to X multiply with partial derivative of W of X, okay, plus partial derivative of W with respect to Y multiply with Y over delta X plus partial derivative of W with respect to Z multiply with Z over delta X. So we have find W over delta Y. Here you will get apa nama dia? X plus Z. So substitute everything in here. Delta W over delta X is delta W over Y. Ini bukan satu, ini Y. Okay, this one will become Y. Delta X over delta X is 1. Plus delta W over delta Y is X plus Z. Delta Y over delta X is cos X plus delta W over delta Z is another one here will be equal to Y. Okay. Plus Y multiply with exponential of X. Okay. So ini adalah jawapan dia, but we were given Z sama dengan exponential X dan Y equal to sin X. Okay. So everything will be in term of X. So from here, sin X plus exponential X cos X plus sin X exponential X. Okay. So, ini jawapan dia. sin x exponential x. Atau kita boleh faktorkan dia jadi 1 tambah exponential x sin x plus exponential x cos of x. Okay. So this is dw over delta x. Okay. Dapat Senyap je budak-budak ni. Dapat semua? Kalau dapat tanda bagus, macam biasa. Okay. So cuba buat next example. Those who have seen it boleh try the next one. Dia kata apa? Use the chain rule to find the partial derivative of z with respect to x if you were given all of the function in there. So yang ini kita wujudkan sahaja. Okay. So the next one, done lah, this one. So I hope everyone is done. So let W equal to P cube Q squared R plus S squared with P sama dengan Y cube plus Z squared and Q sama dengan X exponential Z, R sama dengan XZ squared, S sama dengan XY squared. Masya Allah, banyaknya. Then dia kata, use an appropriate form of the chain rule to find delta W over delta X. W mengandungi variable P, Q, R dan S. So you were given all the P, Q, R dan S. So we have to find partial derivative of W with respect to X. Okay. So if you take a look at this one, W equal to P cube plus Q squared R plus S squared. Okay. So dia nak dapatkan semua dalam bentuk X. So meaning that kalau kita buat dia punya equation, you are going to have delta W over delta X akan sama dengan delta W terhadap delta P multiply with P terhadap X plus delta W terhadap Q bezakan Q terhadap X plus W terhadap R dan bezakan R terhadap X plus delta W over delta S multiply with delta S over delta X. Okay. So tengok all the variable that contains in W. W ada P, Q, R, S, meaning that setiap setiap variable tu we have to find the derivative of each of the variable in there, and we also have to find the partial derivative of each variable with respect to X. So macam itu je cara nak tentukan. Take a look into the equation, what are the respective variable in there, and from there bezakan setiap satu of the variable and bezakan setiap variable terhadap pembawah yang kita nak. Yang kita nak sebenarnya terhadap delta X. Okay. So bezakan terhadap X. So all of these thing that you have to find, kita dapatkan pembezaan bagi W satu persatu dulu. W terhadap delta P dapat 3P kuasa 2. W terhadap Q dapat 2QR. W terhadap R dapat Q squared. W terhadap S dapat 2S. Okay. Then you have all the other variable that is, so P equal to Y cube plus Z squared. Okay. Then awak ada P sama dengan Y cube tambah Z squared. So kita kena dapatkan delta P over delta X. So macam mana? Tak ada X kan dalam tu? So nak buat macam mana? P tak ada X, delta P, delta X tak ada. So it will become 0. Okay. Sebab kita tak ada equation untuk Y dan kita tak ada equation untuk Z as well. So delta P over delta X, it will become 0. Okay. Dan Q equal to X exponential Z. Delta Q over delta X akan sama dengan exponential of Z. Okay. So R sama dengan X Z squared. Delta R over delta X akan sama dengan Z kuasa 2. Okay. Delta R over delta X. So WS sama dengan X Y squared. Delta S over delta X equal to 2 XY multiply with Y. Okay. So masukkan dah dalam the equation. Substitute everything in the equation. Then kita akan dapat W over X akan sama dengan W over P. 3 P kuasa 2 darab kosong. Tambah W over delta Q 2 QR. Delta Q over delta Z exponential Z tambah W over R Q squared delta R over delta X is Z squared. Okay. Tambah 2S didarab 2Y XY. 2Y XY. 2Y XY. Okay. So, ini dia punya sebutan. Then kita gantikan setiap equation. So kalau awak tengok dia dapat ni, sebenarnya you dapat 3P squared dah tak ada. Ni dah become kosong. Okay. This will become 0. Then you akan dapat sama dengan 2QR exponential Z plus Q squared Z squared tambah 4S XY kuasa 2. Okay. Q sama dengan X exponential Z. Okay. Dan R sama dengan X Z squared exponential Z. Tambah Q kuasa 2 X exponential Z kuasa 2. Z kuasa 2 tambah 4. S adalah X Y squared darab dengan XY kuasa 2. Banyak gila sebutan. So dapat 2 X kuasa 2 Z kuasa 2 exponential 2Z. Okay. Tambah dengan X kuasa 2 Z kuasa 2 exponential 2Z. Tambah 4 X kuasa 3 Y kuasa 4. So ini jawapan dia. Partial derivative of W with respect to X. Okay. So yang ini kita gantikan Q sama dengan yang ini. Okay. R is this one. Okay. And then itulah tu. S is this term. So dapat? Okay. Dapat. Soalan tak so far? Done? So then cuba buat the next example. So, harapnya semua orang done with this one. So, boleh try the next example. A rectangular has length 5 feet and width 2 feet. If it is changing in such a way that the length is increasing at the rate of 3 feet per second and its width is increasing at a rate of 4 feet per second, at what rate is the area of the rectangle changing? Okay. Berapa perubahan? So, dia kata area. Area is luas. What will be the equation of area? Okay. So, the next question is stated in here. Okay. Rectangular. Rectangular apa? Segi empat. Dia ada 5 feet and 5 kaki. Panjang 5 kaki, width apa? Lebar. Okay. Dia ada 5, katakan yang ini adalah length L and W. Let the length equal to L and let the width equal to W. Okay. So LW, area of a rectangular equal to width darabkan dengan dia punya length. Okay. So it is changing in such a way that the length is increasing at a rate. So from here it is given this information 3 feet, meaning that this is delta L over delta T. Okay. And its width is increasing. So yang ini pula delta W over delta T. Okay. So at what rate is the area of the rectangle is changing? Meaning that the question what to find delta A over delta T. Okay. So from here, given, okay, given delta L over delta T equal to 3. feet per second. And delta W over delta T equal to 4 feet per second. Okay. So area of a rectangle. Okay. A equal to LW. So delta A over delta T akan sama dengan delta L over delta A over delta L. Okay. The partial derivative of A with respect to the length multiply with length D plus partial derivative with respect to W multiply with dW over dt. Okay. So delta A over delta T, delta A over delta L, bezakan akan dapat yang ini sama dengan, bezakan A terhadap L dapat W. Okay. W darab 3 tambah bezakan A terhadap W dapat L didarabkan dengan 4. So W equal to 6 width of 2. This is W and this is L. Okay. 2 darab 3 tambah 5 kali 4 sama dengan 26 feet per second. So itu adalah the changing, okay, the rate of change of the area of the rectangle. Kadar perubahan. Dapat Jadi bagus. So tengok the next question. Ada lagi satu soalan. Use the chain rule to find delta Z over delta X. So cuba buat that one. Auto kita dah buat. So the next one, kita ada, ni dah buat tadi kan? Apa sebenarnya dah buat je. Oh, ni dah buat kan kelas?
Dah.
Okay. Yang ini sama dengan first example. So dah buat. Okay. So implicit differentiation. Okay. What is implicit differentiation? Differentiation in equation containing x and y, let y be a dependent variable while x be an independent variable. So then y defined implicitly in terms of x. Maksudnya x ada y dan y pula ada bergantung pula terhadap x. Macam itulah dia, x dan y ini saling memerlukan satu sama lain. So tak dapat dipisahkan, tapi kita nak bezakan dia. That's the idea. Okay. So x dan y and y be dependent variable while x be independent variable. So y defined implicitly in terms of x. So in this case, we will call y an implicit function of x, and then a familiar example of the implicit function is, for example, kita ada equation of a circle. X squared tambah y squared sama dengan 9, which represent a circle with radius 3 and centered at origin. Okay. So to obtain the derivative of implicit function, we will apply the implicit differentiation technique to solve for the implicit differentiation. So let's say, for example, so from the application of the chain rule, we can calculate partial derivative. We can calculate the derivative of dy over dx by using the following theorem. Okay. Suppose that we have f is a function of xy and it is differentiable, and the function fxy is equal to 0. Define y as an implicit function, that is implicit function of x, that is y equal to function of x. So partial derivative, the derivative of dy over dx will be taking the negative of partial derivative of the equation f with respect to x divided by partial derivative of the function f with respect to y, by which partial derivative of y cannot be equal to 0. Okay, yang ini partial derivative dia sama dengan fx kecil. But in this case, function dia huruf besar. So it represent the partial derivative. So let's take a look at example to get a better picture about this one. Okay, if dy over dx, find dy over dx if y sama dengan fx. Defines the equation of y squared tolak 3y tolak 2x cube tambah 7x sama dengan 2. Okay, so y sama dengan equation of the function, apa nama dia? Equation of the function fx. Then kita nak dapatkan dy. Okay. So we have the equation here, y kuasa 2 tolak 3y tolak 2x cube tambah 7x sama dengan 2. Okay. So macam mana nak dapatkan dy over dx? Okay. dy over dx equal to what? So from here, kita bezakan partially. You have delta over delta x y squared tolak dengan partial derivative. Okay, this is not partial derivative. Kita bezakan full derivative. D over dx y squared tolak dengan bezakan terhadap dx bagi 3y. Kita bezakan juga terhadap 2x cube tambah dengan 7x sama dengan bezakan setiap term tu terhadap x. So kalau bezakan setiap term tu terhadap x, dia akan dapat 2y, bezakan 2y dan y ni adalah function of x. So you have to write dy dx. Okay. Tolak dengan 3 dy dx. So bezakan x terhadap x ni dapat 6x kuasa 2 tambah dengan 7 sama dengan 0. Okay. So from here, okay. So from here, kalau nak clear sebenarnya kita letak ni lah. 6x kuasa 2 dx over dx tambah dengan 7 dx over dx sama dengan 0. Dx over dx it will become 1. By which dia sebenarnya sama dengan 2y dy over dx minus 3 dy over dx tolak 6x kuasa 2 tambah 7 sama dengan 0. So faktorkan 2y minus 3 tolak 6x squared tambah 7 sama dengan 0. So dy over dx 2y tolak 3 sama dengan 6x kuasa 2 tolak 7. So from here dy over dx sama dengan 6x squared tolak 7 over 2y tolak 3. Okay. So yang mana ini adalah partial derivative of the function terhadap x, dan ini adalah partial derivative of the function terhadap y. Okay, menggunakan formula tadi. So dapat Ini dia punya apa nama dia? Nanti sekejap lagi saya tunjuk kalau guna teorem. Terbeza dia implicitly. Secara tersirat. Ini sebenarnya daripada Engineering Mathematics 1. But let's say for example, we want to use the theorem. Done. Orang je done. So, teorem tadi dia kata y is a function of x. If you take a look at this one, at the theorem, okay, it states in the theorem that dy over dx sama dengan negatif fx xy divided by fy xy. So samalah, bezakan function atas ni terhadap x. Negatif kalau bezakan y terhadap x akan dapat kosong tolak kosong tolak dengan 6x kuasa 2 tambah 7. Okay. Dibahagikan bezakan terhadap y, 2y tolak 3 tolak kosong tambah kosong. Okay. So yang 2 tu akan jadi kosong. So kalau tengok dapat negatif 6x squared tambah 7 per 2y tolak 3 sama dengan 6x squared tolak 7 dibahagikan dengan 2y tolak 3. So sama dapat jawapan dengan macam tadi. Okay. Tu menggunakan teorem. By using the theorem. Okay. Using the theorem. Cuma tadi saya nak tunjukkan secara apa nama dia? Secara mathematically. Macam mana dia dapat macam tu. Done with this one. Okay. So, take a look at the next one. Okay. So take a look at this next one. You want to find partial derivative with respect to two variable function. Let f x y z, function of x, y, and z equal to 0, define an implicit function of f with two variables by which you have z sama dengan function of x, y. Then delta z over delta x equal to find the partial derivative with respect to x divided by find the partial derivative with respect to z. Okay, so z and x, and this one as well. Okay, so partial derivative of z with respect to y will be equal to negative fy over xyz divided by the partial derivative with respect of the z of the f function to z, partial derivative of z function, f function with respect to z. Okay, so delta y delta z over delta x equal to negative fx over fz. Okay, and delta z over delta y equal to negative fy over fz. So dapat? So let's take a look into the example. Okay, find delta z over delta x and delta z over delta y. If z equal to fxy, define the equation of z cube minus xy plus yz plus y cube equal to 2. So from here kita ada the equation given z cube tolak xy tambah yz tambah y cube sama dengan 2. And we would like to find delta z over delta x will be equal to negative fx divided by fz. So dia akan sama dengan bezakan partially the function with respect to x dibahagikan dengan fz. So bezakan partially terhadap x yang awak akan dapat 0 tolak y tambah kosong tambah kosong. Okay, yang 2 tu pun akan jadi kosong. So we don't need to write anything in there for the two function. Okay, untuk 2. Okay, then dibahagikan juga dengan apa nama dia, bezakan terhadap z. Dia dapat 3 z kuasa 2 tolak kosong tambah y tambah kosong. So dapat negatif y per 3z squared plus y. Dapat? So senang je kalau guna teorem. Kalau guna yang awak belajar dalam Engineering Maths 1, sama juga dapat jawapan satu persatu. Kita bezakan, the idea is from what I have shown you in the earlier. Yang first tadi, yang sebelum kita guna teorem. Okay, that is the idea of implicit differentiation. So, delta z over delta y pula sama dengan negatif fy over fz. That is bezakan terhadap y kosong tolak x tambah z plus 0. Yang 2 tu memang habis terus lah sebab dia apa nama dia? Satu constant. Okay. So from here bezakan terhadap z dapat 3 z kuasa 2 tolak kosong tambah y tambah kosong. So dapat negatif apa nama dia? Ini ada negatif tadi kat luar. Kena letak negatif sign. So negatif darab negatif. So dia akan jadi y per 3z squared plus y. Okay. So yang ini pun ada negatif dekat luar. So dia akan jadi negatif of negatif x tambah z over 3z squared tambah y. Sama dengan Oh, yang ini ada lagi satu, Y term. Siapa yang tengah menyanyi tu? Tambah 3Y kuasa 2. Tinggal. Okay. Tambah 3Y squared. So from here dapatlah jawapan dia. X tolak Z tolak 3Y squared over 3Z squared tambah Y. So dapat delta Z over delta Y. Dan lain-lain. Kalau dan cuba beramai-ramai angkat tangan. Ada soalan? Siapa yang ada soalan tu? Ramona.
Tak ada.
Tak ada. Oh, okey. Kan ada soalan tadi. Okay. So kalau done, this exercise awak buat sendiri dan jawapan akhir dia bagi kat bawah tu. So you can try this exercise by yourself. And then kita tengok kepada dah habis. Discard. Okay. So then kita tengok kepada local extreme.